Hey everybody, I'm really excited. I think I have achieved how to improve the dynamic in-context learning for large language models to solve really hard problems. As you can see in the local example, we were able to achieve 93% accuracy on a Kaggle data challenge. You may know from the previous video, but we allow the large language model to observe the data set in time, in sequence, not at once, so over time, and produce these predictive rules on how to treat the problem at hand. So this is a prompt essentially that the model itself is generating for itself to be able to predict uh, unknown cases that it's going to see in the future. So this is what the data set looks like. We are trying to predict true or false, but to do this is very difficult because there are a lot of variables that we need to find the relationship meaning to. And that's what the language model is trying over time. And if we look at the progress, it iterates over and over again, looking at, in this case, 100 rows of this data at each iteration, and and adjusts these rules so that it gets better rating and it gets feedback because it not only generates these rules, then it itself uses these rules to predict. And that is how we are keeping track of the progress. Now, this is pretty mind blowing. And as you can see, there are these two stars at the end. We are actually, so this is the training accuracy, which reached 93% here. But these little stars, actually, validation reached 78%. It validates twice at the end over the exact same validation set. Of course, these are language models, so there is some variability. So essentially, we are converting a language model into a machine learning algorithm via rules that it con- concocts to actually solve the problem itself. So this is a natural language machine learning algorithm, kind of, if you think about it like that. So not only that, these are pretty very specific rules. So what I did is actually I asked Cursor to convert this into a deterministic rule set. So the script you see here does not use any machine learning libraries or anything like that. It just uses deterministic logic, which is representative of this prompt. So essentially, once we have the solution, we can convert it into code. So this is the crazy part. But the system is actually designed to actually use its own prompt to become the prediction engine. Let me try to explain that. If we go into accuracy metrics, so it goes through the iteration. So it looks at 100 rows and then it predicts those rows again to see how good its rule set was. So it not only generates this prompt, then later uses it. And you can see in the first iteration, it got 61%, then 84, 82, and each time it's sampling another 100. Some rows can be mixed in. Yeah, this is just so amazing. But we are able to convert it into deterministic rules, and I can actually run this, and I'll run it real quick. So we now predicted the entire training data set, and we get 7.2%, which is quite high, at least for in the yesterday's example, we were barely pushing 65. By the way, all the code files for this, including all the examples, will be available at my Patreon. Link will be in the description and the comment, depending on where you're watching this from. I also have the previous older versions, the AI prediction engine or dynamic in context learning from the previous video. So I will actually include that. That's going to be under the older version, but all of this will be available at my Patreon if you're interested for paid members. Also, I just want to say there are several files which we're going to take a look at because I explored several different perspectives on this. So essentially, we let me explain it with some charts, or I mean, with some drawings. This is for when I was studying some math. Anyway, so we have a data set. So, but you can think of this as a problem set. I believe this can be adapted to a variety of use cases, which I will try to do in future projects. But imagine this is your data set and you have your large language model. So we sample a subset of this and give it to the language model, and we ask it to create a rule set, which is going to be a prompt, right? To that explains this. Like how is this? How can we like what can we write about this that actually explains this problem, so that once we read this and apply these rules in this prompt or the predictive rule set, that we can actually solve this without knowing the solution. So that's what we're trying to do. But this is just iteration one. So it does this, and then we move on to second iteration. Here we pick another 100, and we predict these, and we give back the results, and then we get an updated rule set, and then we pick another uh, sample from the data set, and we keep doing this. So until we reach a certain threshold or iteration number. So that's what we're trying to do, and that's what this script does. But I've done this several different ways. The simple adaptive prediction actually picks a certain amount of training rows, here in this case, like let's say 300. By the way, you can use the script with any open router model, or you can also use it with OpenAI. It's up to you. So it picks a certain many training rows, and then it writes this rule set, and then it predicts the same 300 again and again. Because my thinking was that just because it has written the rule set doesn't mean that that rule set actually is correct. Because if you show it the rows, the problem set, and it thinks it found the solution, we don't know if it's actually found the solution or where there may be gaps. So we keep running this again and again until the max iterations is satisfied. And I can show you some examples of that too. So those are under the adaptive results, and the more advanced one is under adaptive sampling. So if we look at adaptive results for Rock Code Fast, for example, you can see its chart. Here it actually increased, but as you can see, it overfit. So we can overfit, but if you look at its accuracy metrics, we were only giving it 50 training rows. So it was only working on this 50. And originally I wasn't shuffling the data set, and the data set is kind of organized. So it's, see, as you can see, 010101. I believe that means same family members. So that was a mistake, but this was a good mistake. It was a learning opportunity. Because if we look at the chart again, it means it's over. Like we achieved the language model overfitting at inference time. Like, this is a really interesting phenomenon, right? Via its rule set to this particular problem set. But when I have changed this adaptive results from OpenAI, let's take a look. So I was able to achieve actually better results here. We got 70%, which was our best rule, which is written here. And if you look at accuracy metrics, then we were given 300 training rows from a shuffled set of thing. So this worked. So I'm very happy. So the second idea was that, all right, the second one is adaptive sampling prediction, which does a very similar thing, but except it does the training rows. It picks from the data set in an adaptive fashion, just like we have explained here. So it doesn't use the same set of 200. It picks it from all over. This actually produces better results because then it doesn't overfit. And I have several examples to that. As you can see, this actually achieved immediately the threshold that I set, which was, you can see here, 91%. It actually achieved 96% accuracy. We can now actually use this because I have another script here, predict from rules. We can actually come back here, and where were we looking? Oh, right here. So we can actually grab the relative or the full file path and come back to predict from rules and replace this path and actually run this. Let's go ahead and do it. Here I'm going to say Python predict from rules, and this will actually predict 50. So it's going to pick 50 samples randomly for five parallel runs. So we are actually predicting 250, 50 from all across the data set to get an idea of overfitting. So we are picking 51 from here, one from here, one from here, right? And from different areas of the data set, just to get an idea of how accurately it's predicted. Not only that, we can also so we can use any model we like during training, but we can also use any model we like during inference. And so, just because these rule sets were created, if you take a look, it needs to be accurately be understood by the model, right? That's why actually, if you run this multiple times on the exact same sample of rows of data to predict, you're going to get slightly different results each time. That's why I was sampling twice, as you can see, to see the variability in between them. So the closer they are, the better it is. But here, although it achieved 96%, uh, only over 50, it actually didn't do so bad, but it still was way below because this is a case of overfitting. And we can see here, in our first 50 rows, we got 68%, 70%, 70%, which is which is in line with this result that we saw from the validation from the training run. Hmm. So it's very interesting. I was very happy that this worked. There's so many other ideas I have to try to improve it. So let's actually do something even together. And I'm going to make sure that I add this predict with determinism to cursor. And I'm going to say, can you please write a new script, which is the exact same script as the predict with determinism rules, .py, but this will actually predict the train.csv and create a submissions file, submit to the Kaggle challenge. And all we need is really the IDs and the label as true, false. Okay, let's run this real quick. This is going to be quick because Grok code is very quick. I really love Grok code. I love the combination of Grok code with GPT-5. And I'm going to make a separate video on that. But Grok code is very, very good model. It's a great model, in my opinion. Here we go. It's done. Create Kaggle submission. Close some of these. Let's go ahead and accept. I'm going to assume this is good. Let's just quickly run it. Maybe it'll print. Oh, it can't print total predictions. So we have now submissions.csv. We can submit to this challenge. Okay, I'm at Spaceship Titanic. I'm going to submit, browse to my folder, click on submission, open it, and now submit, and we'll be able to see what. Oh, we got an error. 4,277 rows. Okay, it actually predicted train.csv. Okay, uh, that's an easy fix. We just need to change. Let's search for train. It's not train. It has to be test.csv. Let's run it again. Should be quick. Here we go. 4,277. This is what the error was about. Cancel that. So submit the prediction again. Submit. and we'll be able to see the score at 75%. So this would have been decent. If you look here, 75 would have scored not so great. It would have scored kind of towards the bottom, but it's still something. So I'm going to try to work on it to work some kinks out and actually get it to do better. But okay, but the thing is that we are actually doing this with the deterministic prediction. If we actually were to do it with a large language model here, as we did, and if we achieve close to the 79.6%, then we'll be in a totally different position. We would actually be more than halfway. 79.6 would put us around 700, which is on the top 50%. We can just push it one percentage point, which I believe will be able to. Then we'll be able to score in the top 30, top 20%. So this is remarkable to me. And this is all I had to say about this. I'll create a README file and then upload this to my Patreon. You'll be able to download it from there. Thank you for watching. I hope you found this useful. And, you know, when you're at my Patreon, take a look around because I do have over 400 now, probably by now over 500 useful, interesting apps. Almost all of them are around large language models. As a paying member of my Patreon, you will have access to all of them, exclusive videos, weekly meetings with me on Sundays. And also, if you'd like to speak with me one on one, I do have membership levels that allow you to have consulting meetings with me. Whether you want to learn something, pick my brains, or just want to talk to me, or need help with your project, consider that as well. You should be able to find it in the membership page through the link on the description on the comment, depending on where you're watching this from. Thank you again and take care.